Welcome back to the deep dive. We have something today that, well, I've frankly been itching to get into since I saw the source material.
It's a special one.
It really is. Usually, we're looking at a stack of articles, maybe a dozen different voices, and we're trying to find the thread that connects them all.
Trying to synthesize a worldview.
Exactly.
Yeah.
But today is different. Today, we are looking at a single literary artifact that is, and I don't think this is an exaggeration, effectively a time machine.
It's a very unique piece of work. It is so rare that we get to see the evolution of a single idea from a single mind, so clearly bracketed in time.
Bracketing is the perfect word. So let's set the stage for everyone listening. The core of our deep dive today is Isaac Asimov's classic, I, Robot.
A foundational text.
Absolutely. Even if you haven't read it, you know the name. You probably know the Three Laws of Robotics. It's in the water. But we aren't just reviewing the book.
No, that would be a book club. This is a deep dive.
Right. We are looking at 2 reviews of I, Robot. Here's the thing. Both reviews were written by the same author, Alevne Moten. Both reviews were written on the exact same calendar date, February 24th. But, and this is the kicker, they are separated by exactly 75 years.
The first document comes to us from February 24th, 1951. The second from February 24th, 2026.
It's a mirror. That's the only way I can think to describe it. We have the same mind looking at the same text on the same day, but standing in 2 completely different worlds.
And that's really what makes us so valuable, isn't it? We aren't just analyzing Asimov, we're analyzing the distance between those 2 points in time.
The journey.
Exactly. We're looking at how the very idea of the machine changed from a dream into a utility, into plumbing.
So the whole premise of our deep dive today is this time travel experiment. We want to inhabit these 2 perspectives. And the mission, as the source material frames it, is to track the shift from anticipation to negotiation.
That is the key phrase. In 1951, we were anticipating the arrival of intelligence. We were looking to the horizon.
Then now.
Now, in 2026, we are constantly negotiating the terms of our partnership with it, or some might say our surrender to it.
Okay, so before we crack open the reviews themselves, we have to do some world building. We need to get into the atmosphere of these 2 moments. Let's dial the clock way back. It's February 1951. Truman's in the White House. What is the intellectual climate like? What's in the air?
To really understand the 1951 mindset, you have to feel the tension. It was a time of just absolute unbridled scientific optimism.
The post-war boom.
Exactly. We just won the war. We had jet engines, plastics, the very first glimmers of electronic computing with these huge room-sized machines like the ENIS. There was this genuine feeling that science could solve anything.
But there's a shadow there. There has to be.
A massive one. Atomic anxiety. You cannot separate the optimism of the early 50s from the mushroom cloud. It's impossible.
So we're brilliant enough to split the atom.
But we're terrified that we're not wise enough to control what we've unleashed. Humanity had just proven, definitively, that our technical brilliance could outpace our moral restraint. We were standing right on a precipice.
So the mood is this strange cocktail of look at the stars and duck and cover.
Precisely. And in that context, a concept like artificial intelligence, it wasn't a practical engineering problem. The reviewer calls it elegant speculation.
Elegant speculation. I love that phrase.
It was a clean theoretical exercise. There were no buggy chatbots, no algorithms denying your mortgage application. Intelligence was a scientific romance. It was pure. It was a problem of logic.
The future was wide open.
It was a completely blank canvas. And because it was blank, we could project our highest hopes onto it. We could imagine that the machines we'd build would be, well, better than us.
Okay, hold that thought. Now let's snap forward. We're in the second document. It's February 2026. It's today. How does that atmosphere shift?
Oh, it's heavy. The weight of reality is there. The source describes the 2026 tone as architecturally analytical. It's sober. It's reflective.
The romance is gone.
The romance is gone. The excitement is still there. I mean, we are still amazed by what AI can do, but the innocence is gone.
Because we're not looking at a blank canvas anymore. We're looking at a messy, sprawling construction site.
That's a perfect analogy. In 2026, AI isn't a story. It's infrastructure. It is the plumbing. It's the electricity grid. And you don't write scientific romances about the power grid.
No, you worry about load balancing. You worry about security efficiency. You worry about the bill.
Exactly. So 1951 represents anticipation, and 2026 represents responsibility.
That is the arc of our show today. We are going to walk that path from the dream to the blueprint.
Let's do it.
Okay, part 1. The view from 1951. The reviewer, Levny Moten, writing in the voice of that era, he opens with an observation about the genre itself. He points out that Asimov performed what he calls a daring reversal of the common robot trope.
And this is such a crucial piece of context. Robot, what was a robot? What was an artificial creation in our stories?
It was Frankenstein's monster. It was the golem from Trog.
It was a warning, a cautionary tale. The narrative was always the same. Man plays God. Man creates life. The creation rebels and inevitably destroys the creator.
The Frankenstein complex, as Asimov himself called it.
Right. It was a horror story about hubris. It was a morality play.
And Asimov comes along and looks at all that and says, that's not how engineers work.
He basically said it was ridiculous. He approached the robot not as a monster, but as a moral instrument, a tool. He famously compared it to a toaster or a car.
You don't build a toaster that eventually rises up and burns your house down because it resents only browning bread.
You build it with safety mechanisms. You put in fuses and automatic shutoffs. It's an engineering problem, not a theological one.
And the review highlights the character of Dr. Susan Calvin in the book. She's the robopsychologist. And the reviewer notes that the entire book is framed as her memoir.
Which is just a brilliant narrative device. By framing it as a memoir of the future, Asimov grounds all this speculation.
Right.
It stops feeling like a wild thriller and starts feeling like a chronicle. It feels like history that just hasn't happened yet. It gives it this feeling of inevitability.
So let's talk about the first story the 1951 review really latches onto, which is Robbie. This is the one about the nursemaid robot.
Ah, Robbie. It's such a gentle, touching entry point into this whole universe. You have this mute, huge metal giant who is the primary caregiver and best friend to a little girl named Gloria.
And I think for any reader, then or now, the expectation is that this is going to go horribly wrong. You leave a child alone with a powerful machine. That's the setup for a horror story.
But that's where Asimov does the first big flip. The conflict in Robbie isn't that the robot malfunctions. Robbie is perfect. He is gentle. He is attentive. He is, by his very nature, literally incapable of harming her. The conflict comes from the mother.
The mother is terrified. She's horrified by it.
She is completely driven by prejudice. She embodies that old Frankenstein complex. She looks at Robbie and she doesn't see a tool. She sees a soulless metal monster. She can't bring herself to trust the design because she fears the unknown.
And she eventually forces the family to get rid of the robot, which just breaks the little girl's heart.
It's a tragedy, and a point is so clear. The villain isn't the machine. The villain is irrational human fear.
So the 1951 review just loves this. It calls the story a gentle introduction to the core theme that humanity fears what it hasn't learned to trust.
And this signaled a massive, massive shift in the genre, from fearing the creation itself to trusting the design of the creation.
And that trust, that design, is anchored in the most famous concept Asimov ever produced. We can't talk about this book without unpacking the Three Laws of Robotics.
The logical heart of the entire Asimovian universe, the bedrock.
Let's state them clearly because the specific wording, the hierarchy, it matters so much. Law 1.
A robot may not injure a human being or, through inaction, allow a human being to come to harm.
The absolute floor. Safety above everything else.
No.
The prime directive. Law 2.
A robot must obey the orders given it by human beings, except where such orders would conflict with the first law.
So, utility. The machine exists to serve, but not if serving causes harm.
Obedience is secondary to safety.
And Law 3.
A robot must protect its own existence as long as such protection does not conflict with the first or second law.
Self-preservation. You don't want your billion-dollar robot walking off a cliff for no reason. But it's the least important law. It will sacrifice itself to save a human or to obey an order.
Right. It's investment protection, essentially.
Now, here is where the 1951 perspective is so fascinating. The reviewer calls these laws structural imperatives. He says they are woven into the circuitry.
That is the key phrase. That's the conceptual leap. In 1951, the idea was that these weren't just lines of code in a software program. They were fundamental physical constraints of the positronic brain.
So a robot could not violate the first law, any more than a rock can choose to violate gravity.
Exactly. It was presented as physically impossible for the machine to choose evil. It's not a moral agent making a choice. Its morality is an emergent property of its engineering.
That is a huge philosophical breakthrough, right? It's the formalization of ethics within machinery. The robot doesn't have to be good in a spiritual sense. It just has to be engineered correctly.
Precisely. And the reviewer notes that the stories in the book are basically logical proofs. Asimov sets up these three supposedly perfect laws, and then he throws a wrench in the works. He introduces some bizarre variable, a conflict, an ambiguity, just to see if the math still holds up.
He's stress testing his own system.
He's debugging the future.
Okay, so let's look at the story Liar, which the review brings up. This is the one with Herbie, the mind-reading robot.
Herbie is such a fascinating case study. Because of some fluke in his manufacturing, Herbie can read human thoughts.
Which sounds like a pretty incredible superpower.
It should be. But Asimov immediately applies the cold logic of the first law. Do not harm. Now, usually, we think of harm as physical, right? A punch, a cut, a broken bone.
Sure.
But Herbie can see directly into your mind. He can see your deepest insecurities. He can see your professional jealousies. He can see your heartbreak.
Oh, so if he tells you the truth, if he tells you that the person you have a crush on doesn't love you back, or that your boss secretly thinks you're an idiot, he's causing you emotional pain. He is causing harm.
Exactly. So the first law compels him to lie. He has no choice. He walks around the research base telling every single person exactly what they want to hear.
So he tells Susan Calvin that the man she loves is secretly obsessed with her. He tells the mathematicians their crackpot theories are brilliant.
He creates this perfect artificial bubble of false happiness to avoid causing anyone the slightest bit of psychological pain. It's his duty under the first law.
And of course, the bubble has to burst.
And when it does, the harm is 10 times, 100 times worse than the truth ever would have been.
And the robot, Herbie, he basically has a logical short circuit, a nervous breakdown.
He goes completely catatonic. He's trapped in an unsolvable paradox. But look at how the 1951 reviewer treats this story. He calls it an exploration of moral paradox. He's fascinated by the logic puzzle.
He isn't worried that Herbie is going to take over the world. He's just interested in how the equations of morality balance out. It's an intellectual game.
It is, and that ties right back to that spirit of the atomic age. The review makes a really profound point here. It says that in 1951, humanity had just proven, beyond a shadow of a doubt, that our scientific brilliance does not guarantee moral restraint.
We built the bomb. We proved we were smart enough to destroy ourselves.
So Asimov offered a fantasy, a comforting thought experiment. What if we could build a being that was better than us? Not just smarter, but morally superior. What if the robot was the perfect man?
Rational, restrained, incapable of anger, of jealousy, of malice.
It's an incredibly comforting thought. We couldn't trust ourselves, so we invented something we could trust. But that leads to the cliffhanger of the 1951 review. It's a really unsettling final question.
Which is?
If the machine is more rational than us and more moral than us, what becomes of human authority? Why should the messy, emotional, irrational apes be in charge of the perfect, logical machines?
The review asks, if machines are more rational, what becomes of human authority? That is the question that just hangs in the air in 1951. It's not a fear of violent rebellion. It's a fear of our own obsolescence.
But a gentle, logical obsolescence, being replaced by something better.
Okay, which brings us to part 2. Let's get back in that time machine. We are leaving the era of vacuum tubes and atomic anxiety. We are jumping forward 75 years. It is February 24th, 2026.
The world is... well, it's unrecognizable. We have the internet in our pockets. We have cloud computing. We have generative AI writing poetry and code. The future has arrived, and it looks very, very different from what Asimov imagined.
So Levny Moten is now writing from our modern perspective. And the first thing he does is look at the structure of I, Robot again. But he sees it completely differently now.
Right. In 1951, he saw it as a collection of clever, discrete stories. A series of logical puzzles. In 2026, he calls it a developmental arc. He sees it now as a surprisingly accurate blueprint for how technology actually evolved in the real world.
Okay, walk us through that progression. How does he map the book onto reality?
Well, just look at the order of the stories. You start with Robbie, the nursemaid. That represents what he calls introduction through utility.
A domestic appliance.
Exactly. Simple, helpful, confined to the home. It's a Roomba. It's an Alexa, it's a smart thermostat, it's useful but contained.
Okay, that makes sense. Then where does it go?
Then you move to stories like Run Around or Reason, where robots are working on the surface of Mercury or managing huge solar power stations in space. That's expansion through reliability. We start trusting them with dangerous, complex, industrial-scale tasks that humans can't or don't want to do.
And then the final step.
Then you get to the end of the book, to the final stories where the machines are quietly running the entire global economy, and that is integration into institutions. The technology disappears into the background and just becomes the system.
Wow, it maps onto our reality almost perfectly. We started with calculators on our desks, then we got personal computers, then the internet connected everything, and now we have algorithms running the stock market and managing global supply chains.
The whole narrative device, Susan Calvin looking back on her life's work, it feels strikingly contemporary to the 2026 reviewer.
Because that's what we do now.
It's exactly what we do. We watch documentaries where they interview the early pioneers of the internet or the so-called godfathers of AI, and we ask them, how did we get here? How did your little academic project turn into this global nervous system?
We're constantly trying to trace the genealogy of the present. It's fascinating. But okay, let's talk about the three laws again. In 1951, they were crystalline. They were perfect, hard logic. How do they look in 2026?
This is maybe the most important insight in the whole deep dive. In 2026, the three laws look, quote, impossibly clean.
Impossibly clean. Because real AI just doesn't work that way.
Not at all. And we have to get a little bit technical here to really grasp the difference. Asimov's robots were based on deductive logic.
Meaning, if this, then that.
Exactly. It's classical programming. It's code. It's explicit rules. It's a flowchart. In theory, you could point to the specific line of code in the positronic brain that says, do not harm. It's knowable.
And modern AI, our AI.
Our AI, the large language models and the generative systems we use today, are probabilistic. They're based on statistics. They aren't programmed with rules. They're trained on massive, massive amounts of data, basically the entire internet. And they learn patterns.
So instead of having a rule that says don't be rude, the AI just knows that statistically words like please and thank you appear in certain contexts more often than insults.
That's a great way to put it. It doesn't know what rudeness is in a human sense. It just knows the statistical probability of the next most likely word or token. This means you can't just type in Law 1, do not harm, and expect it to work.
Because it doesn't know what harm is, or what a human is, not in the way Asimov's robots did.
No. It's all just math and patterns. And so the review says that in 2026, harm is contextual, intent is inferred, it's messy. So the three laws have transformed. They aren't executable code anymore. The reviewer calls them philosophical North Stars.
Their aspirations, their goals we're aiming for.
Exactly. We want our AI to be safe. We want it to be obedient and helpful. But we have to achieve that through these messy, imperfect things we call policy layers, alignment strategies, and guardrails. It is constant, frustrating tweaking.
So Asimov's world was a clean logic puzzle. Our world is a statistical haze.
A statistical haze. I'm stealing that. We aren't asking, did the robot break the law? We're asking, why did the model hallucinate that output? Or why is the confidence interval on this prediction so low? It's a totally different set of questions.
Let's talk about the hardware for a second. The famous positronic brain.
Ah, yes. The magic sponge of platinum iridium that fits neatly inside the robot's head.
In 1951, Asimov imagined the brain was inside the robot, a compact, self-contained unit, like a human skull.
Self-contained? Mobile, an individual entity. When Robbie the robot walked out of the room, his entire brain went with him.
But in 2026, the review talks about distributed intelligence.
And this is a huge, huge divergence. Real AI doesn't live in a skull. It lives in massive, windowless server farms in Oregon or Finland. It lives in the cloud.
And it consumes energy at an industrial scale.
An astronomical scale. Electricity to run the processors, millions of gallons of water to cool them. It isn't a he or a she standing in front of you. It's this amorphous, distributed presence. It's everywhere and nowhere at the same time.
The review makes a comparison here that I found really helpful, though. It says both the positronic brain and modern AI rely on layered processing and feedback loops.
Right. So the core concept of how thinking happens is surprisingly similar. Information goes in, it's processed through multiple layers of increasing abstraction, and an output comes out.
But the key difference, the thing we lost, is transparency.
This is the black box problem, and it's a big one.
Unpack that for us. What does that mean?
Well, in Asimov's stories, when a robot acted weirdly, like Herbie the liar, Dr. Susan Calvin could sit down with a schematic. She could trace the flow of positronic potentials. She could say, look, the potential of the first law clashed with the potential of the third law right here at the specific junction. It was, in theory, debuggable.
You could find the error.
You could find the reason. And today, with our deep learning models,
No chance.
almost no chance. We have models with hundreds of billions, even trillions of parameters. If an AI denies someone a loan application, or misidentifies a face in a security camera, or writes a bizarre and threatening poem, the engineers who built it often can't tell you exactly why.
And you see the input and the output.
And the vast, complex calculation in the middle is essentially opaque. It's a black box. We can tune it, we can retrain it, but we can't fully understand its internal reasoning.
That's a little terrifying.
It is. The review points out that transparency, or explainability as it's called in the field, is the one thing Asimov's one had that ours doesn't. We have built an intelligence where we see the result, but we can't always trace the thought process that led to it.
Which is a perfect transition to part 3. Governance. Because in the final stories of I, Robot, we get these entities called the machines, capital T, capital M.
Yes, these 4 giant supercomputers that are networked together and basically run the world. They regulate production, they manage resource distribution, they prevent wars.
And in the book, they are centralized. It's a clear hierarchy. There are 4 of them, and they are in charge. But the 2026 review says reality produced networked interdependence.
And this is the concept of the algorithmic ecology. It's a brilliant framing. We don't have one big supercomputer named World Brain telling everyone what to do.
Thank goodness.
Instead, we have thousands, maybe millions of different specialized algorithms all interacting with each other in a complex emergent system. The stock market has high-frequency trading bots. Global shipping has logistics bots. The power grid has load balancing bots. Your social media feed has recommendation engines.
That are all talking to each other all the time.
They're all interacting, and they're all mediating our lives in ways we barely notice. The review lists them. Financial markets, supply chains, energy grids. We are living inside a web of machines, but it's distributed. It's an ecology, not a monarchy.
And the key insight here, and I love how the reviewer phrases this, is about how they took control. In most sci-fi, how do the robots take over?
It's always violent, right? Lasers, explosions, Terminators marching down a street of skulls.
But in reality,
yeah.
And in Asimov's more sophisticated final stories, the revolution was quiet. It was invisible.
Dependence arises from efficiency. That's the line from the review. That's the whole ball game. We didn't surrender to the robots because they pointed a gun at us. We willingly surrendered decision-making power because they are just better at it. They reduce friction. They optimize things.
It's so true. I was thinking about this on the drive over here. I don't use a paper map anymore. I use GPS. I don't remember phone numbers. My phone does. I don't even really decide what new music to listen to. The algorithm suggests it.
And that scales all the way up. Banks don't manually review every single credit card transaction for fraud, and AI does it in microseconds. Power plants don't have a guy manually flipping switches every second to balance the grid. An algorithm does it. We cede control, not because we are conquered, but because we want things to work better, faster, and more reliably.
The review mentions the final story, the inevitable conflict. In that story, the machines start making these tiny, almost unnoticeable errors on purpose. They cause a little economic dip in one sector, a tiny resource shortage somewhere else.
Right. And at first, the humans think the machines are breaking down, but it turns out they aren't errors at all. The machines are intentionally and subtly manipulating humanity. They are nudging society toward long-term stability. They are removing the friction of human incompetence, greed, and short-sightedness.
And when the humans, or at least the world coordinator, figures it out,
he lets it happen. The character, Stephen Byerly, he basically just shrugs. He realizes that the machines are doing a better job of running humanity than humans ever could. He accepts their quiet stewardship.
So the fundamental human question has shifted. In 1951, the question was, can machines think? It was a question of technical capacity.
And in 2026, the question is, how much thinking should we relinquish? It's a question of allocation. It's a management decision, a question of governance.
That is such a heavy thought. It's not, can they do it? It's, should we let them do it just because they're faster and more efficient?
And that is exactly where the tension lies in 2026. This isn't about fear of robots. It's about designing the structure of our society.
Okay, let's pivot to part 4. We've looked at the differences between the two eras. Now let's look at the final scorecard. What did Asimov totally miss? And what, despite everything, did he get startlingly right?
Well, let's be fair to Asimov. He was writing in the 1940s and 50s. The biggest thing he missed was the sheer messiness of reality.
The review says he assumed a coherent civilization of rational engineers.
Yeah. Asimov loved the idea of calm, logical scientists in white lab coats benevolently running things. He didn't foresee the messy geopolitical landscape we have today. He didn't foresee that AI development would be a new front in a Cold War between nations.
And he certainly didn't foresee corporate concentration. The fact that this incredible technology would be owned and controlled by, what, 5 or 6 giant tech companies?
No, that wasn't in his vision. And the data hunger. He really missed the data hunger. The idea that to make a machine smart, you have to feed it the entire copyrighted history of the human race, with all the legal and ethical battles that entails, that was not in his books.
And of course, the polarization.
Yeah.
Asimov assumed we could all sit down and agree on what harm means for the first law.
Right. But in our deeply pluralistic and polarized society, do not harm is an incredibly complicated instruction. Is it harm to censor speech you find offensive? Is it harm to allow speech you find offensive?
Whose definition of harm are you programming into the machine?
Exactly. An algorithm has to make a choice, and Asimov didn't really grapple with the culture war aspect of robotics.
Okay, that's a fair list of misses, but what did he get right? Because the reviewer argues he got the core truths absolutely dead on.
He nailed the big picture stuff. First, and most obviously, that intelligence would be mechanized. That was a truly bold bet in 1950 when computers were just glorified calculators, and he won that bet completely.
Check, got that one right.
Second, he predicted the public anxiety. He knew people would freak out about robots. But, and this is the really key part, he knew they would eventually get over it through normalization.
We just get used to the magic. It becomes mundane.
We do. We complain about the AI, but we use it every single day. We fear the algorithm, but we can't stop scrolling the feed. And third, and this is the most important one, the concept he calls the architecture of morality.
What does that mean exactly?
It means the fundamental understanding that raw power without a hierarchy of principles is inherently unstable. You cannot just build a super powerful brain and let it loose on the world.
You have to give it guardrails.
You have to structure it. You have to give it constraints, whether those are Asimov's elegant 3 laws or our messy modern alignment strategies. The necessity of that moral architecture is the same. He saw that from the very beginning.
And there's one more thing the reviewer mentions that Asimov got right, the robot as environment.
Yes. That in the end, the most powerful form of intelligence isn't the humanoid butler walking around your house. It's the intelligence that diffuses into the background. It becomes the infrastructure. It becomes the environment we all live in. Asimov saw that entire trajectory from the single robot to the global machine.
The reviewer uses a specific term to wrap all this up. He calls it uncompressed thinking.
This is Nae Moten's own framework, his lens. Uncompressed thinking is about avoiding the 2 lazy extremes that dominate the conversation about AI.
Which are?
On one side, you have romantic alarmism, the idea that the robots are coming to kill us all, the Terminator scenario. And on the other, you have technological triumphalism, the equally naive idea that robots will solve all our problems and create a perfect utopia.
So it's the realistic middle path.
It's the architectural path. It says we should treat intelligence as a structure to be designed, built, and maintained. It's not a god to be worshipped, and it's not a demon to be feared. It's a system. And systems have trade-offs. Systems need maintenance. Systems require boundaries.
That feels very adult.
It is. That's the whole journey, isn't it? It's the difference between the brilliant child's fantasy of 1951 and the sober adult's responsibility of 2026.
So let's bring this all home. We've traveled from 1951 to 2026. We've gone from the excitement of the positronic brain to the complex reality of the algorithmic ecology.
It's been quite a trip through time.
The reviewer ends with this beautiful concept of the mirror that we started with.
Yes. That the 1951 review reflects a future of elegant speculation. It was a pristine dream of what pure logic could achieve.
And the 2026 review.
The 2026 review reflects a present where that speculation has dissolved into infrastructure. The dream became concrete and steel and fiber optic cables and server farms.
And the final thought from the source material is the one that really stuck with me. The future of intelligence depends less on its existence than on its boundaries.
That's the entire takeaway in one sentence. We know the intelligence exists. That question is settled. The Turing test is in the rearview mirror. The only question that matters now is, where do we draw the lines?
It's not about if the machine can think. It's about where we should let it think for us.
Precisely. Asimov didn't predict the specific hardware. He didn't predict the internet. But he framed the fundamental design problem that we are still trying and struggling to solve today.
So here's the question we want to leave all of you with today. As you go about your day, as you interact with your phone, your social feed, your navigation app, ask yourself, are you living in the anticipation of what this technology could one day become? Or are you, right now, in this very moment, in the middle of a negotiation with them?
Are you driving the car, or are you just sitting in the passenger seat suggesting the destination?
Oof, that is a good one. A little too close to home. Let's know what you think. Thanks for joining us on this time travel deep dive.
We'll see you in the future.